In this video, we're going to study how ionic compounds form, and we're going to try to represent that using Lewis dot structures. So remember that ionic compounds form when you have metals and nonmetals coming together. And the way they form is by electron transfer. So their valence electrons are transferred, they form opposite charges, and they attract. We'll take a look at an example with that with NaCl. So your first step when you're trying to show the ionic compound form is you draw the Lewis structures of both elements side by side. So we have Na is in group 1, Cl is in group 17, so 1, 2, 3, 4, 5, 6, 7. And then you circle the electron on the metal and you transfer it to the nonmetal until the nonmetal is stable, meaning it has 8 valence electrons. And you can see here that sodium only has 1 to give, so it's going to lose that electron, transfer it over to chlorine, and at the end, sodium will be positive, like this, and chlorine will be negative. And because they have opposite charges, this here is the compound NaCl. You can actually name this by just naming the first element sodium, and in the second element you'd change the ending to IDE, chloride. So sodium and chlorine become sodium chloride. And so we showed the transfer of the electron, and we showed the opposite charges, and now they're attracted because this is the cation and this is the anion. We'll try another one. We'll do MgCl2. So here we have MgCl2. You'll notice that there's 1 Mg and 2 Cls. So what I usually do is, if there's only one metal, I draw it in the middle. 1, 2. And then I draw the nonmetals on opposite sides. They have 7 each. So 1, 2, 3, 4, 5, 6, 7. And over here, same thing. 1, 2, 3, 4, 5, 6, and 7. As you can see, magnesium wants to lose 2, and chlorine only wants 1. So if there was only 1 chlorine, it wouldn't be able to lose 2. Magnesium could lose 1. That's why you need to have 2 chlorines reacting with magnesium so that it could lose 2 electrons. One goes to this one, and the other goes to this one. And so at the end what we have is the chlorine on the left side gained an extra electron, so it's -1. Magnesium lost 2 electrons, so it's 2+. And then chlorine on the other side gained an electron, so it's -1 or 1- as well. So you can see that there's 1 magnesium, 2 Cls. The charge overall is 0. And what you have is you name the metal first, so we have magnesium. And the nonmetal, you name it as well, but you change the ending to IDE, chloride. We'll do one more example, and then you'll try one on your own. We'll do the compound between Li and O. Notice I didn't tell you how many you need, so you'll have to figure that out. So we'll do the example down here. We'll start off by drawing Li and O side by side. 1, 2, 3, 4, 5, 6. You'll see lithium wants to lose 1, and it can, but oxygen needs 2. So you'll know that you probably need another lithium to make oxygen happy. So you keep drawing them until you can make both happy, where the metal can lose all and the nonmetal can gain what it needs. So this lithium here will also transfer, and so what we'll have is a positive lithium because it lost 1 electron, a negative oxygen because it gained 2 electrons, specifically 2- since it gained 2, and on the other side a positive lithium. So usually you write the metal first, Li. There's two of them. 2, because there's 1 and 2. And then there's only one O, so O. So if you want to name this, you would name the metal first, lithium. And then oxygen, you would change its ending to oxide, IDE. So you can pause the video and you can try the compound that forms between Al and O, and then between Al and F. After you've paused the video and tried it, you can unpause and check your work. So you're unpausing now, check your work. We'll do the compound between Al and O. So you would notice if you draw Al and O, you'll first get 3 electrons around aluminum because it's in group 13. For oxygen, you get 6 electrons. Aluminum wants to lose 3, and it can at least lose 2 with this one oxygen here, but it's not enough. So you'll draw another oxygen so that aluminum can give up another one, like this. But then what you'll notice is that this oxygen is not happy. It still needs another. So we'll add another aluminum in. 1, 2, 3. To give that oxygen another one. But then now what happens is this aluminum is not happy. So we'll add another oxygen in. 1, 2, 3, 4, 5, 6. And it only has 2 more to lose, so it can give away 1 here and 1 here. So now all the aluminums have lost what they need, and all the oxygens have gained what they need. And so what you basically have is 2 aluminums and 3 oxygens. There's a few different ways you can write this. You can write it alternating, so you can write, for example, aluminum 3 plus, O 2 minus, aluminum 3 plus, O 2 minus, and then you can put another aluminum 3 plus, or another oxygen. Over here. You could also write it like this. You could put 2 Al 3 plus, and then you can write 3 O 2 minus. You could do that as well. But if you were to write a formula for this, you simply have 2 Als and then 3 Os. With the metal first, the non-metal after. And to name it, we have aluminum, and then oxygen becomes oxide. So this is the structure, and then this is the formula, and this is the name. So we have the structure, formula, and name. Structure, formula, or structure, name, and formula. Structure, name, and formula. Over here, we did that for aluminum oxide. Now try for the compound that forms between Al and F. So you've already tried it, assuming you're unpausing the video to check your work. You start off with aluminum, has 3 valence electrons. You draw fluorine, has 7 valence electrons. Fluorine just needs 1. But aluminum wants to give away more. So let's do another aluminum, another fluorine. This one can donate here. I'll do another one over here. Doesn't have to be on this side, but I'll do it here anyways. And then this one can transfer to that one. And so what happens now at the end is we have aluminum that lost 3. And then we have fluorine gained 1. So 1 minus, another fluorine gained 1. 1 minus, and another fluorine gain 1, 1 minus. So you could write this as a formula, metal first all the time, 1 aluminum, you don't have to put the 1 because there's 1. Fluorines, there's 3. So our metal is aluminum. Our nonmetal was fluorine, so it becomes fluoride. So we have the structure, the formula, and the name. You could have also written this structure as Al 3 plus, and then we'll put 3F 1 minus, like that. So that would be your structure. In this lesson, we saw how ionic compounds form. We represented that with Lewis structures. We saw that ionic compounds form by a metal and nonmetal transferring electrons. The metal always transfers the electrons to the nonmetal because they don't hold on to the electrons as tightly. To draw it, you draw the Lewis structure side by side. You circle the electrons to show the transfer. You draw as many Lewis structures as you need for the metals to lose all and the nonmetals to gain what they need to have 8. Then once everything's happy, you can write the final structure as charged ions, cations, and anions, alternating between negative and positive because they attract. Or you could write it with big numbers in the front just to show how many there are. Your formula is simply done by writing the metal first with how many there are, and then the nonmetal next with how many there are. If there's a 1, you don't have to write a 1. You can just leave it as is. And then to name it, you just name the metal first, and then name the nonmetal, but change the ending to IDE.